Okay, I want to try to explain something that's just occurred to me on a kind of a really big scale.
Electricity and magnetism, here we
All
go.
right, I got my shit together here. I'm going to try to work this out one time and not have to do it again. So we're going to look at a graph, but we're also going to look at reality at the same time. It's going to be kind of a difficult, yeah, we'll just see what happens. Anyway, so this is going to be the scale of the graph, and also this is going to be a reality thing, so bear with me. So up here, this is like the ionosphere, and then down here you have like the Earth, and then let's say here we have frequency, and let's say that here we have amplitude. The reason I spelled out amplitude is because over on the other side here we're going to have voltage. And over here we're going to have amperage. Alright, so then we're going to put a plus sign up here and a minus sign down here. And we're going to put a plus sign down here and a minus sign up here. And between voltage and amperage, we're going to put resistance in this direction. And between frequency and amplitude, in this direction, we're going to put impedance. And by this direction, I mean that if impedance moves this way on this line, that would be minus. If it moves this way on this line, it's minus. So in the middle is the most positive position for impedance. And with that in mind, this graph becomes three-dimensional now. So let's see, I'll draw that part right here. So then you have a cone, so to speak, where at the top where the ionosphere is, and it gets broad like this at the bottom where the Earth is. This thing's gonna fall over. So here you have the Earth, and here you have the ionosphere. And so when impedance matches, then you move into the situation of the Tesla coil where you would have an ionization at the top of the coil, which is the static discharge, and that's by impedance matching. And so by lowering resistance, you can increase voltage and amperage, but by matching impedance, you move into another type of energy that's more static. So as you move into higher frequencies, you get lower amplitude. See, so as the frequency increases, the amplitude decreases. And as the voltage increases, the amperage decreases. It's a trade-off. So as the Earth is more negative and the ionosphere is more positive, then at the Earth level, you will have more amplitude and more amperage on the magnetic end of the spectrum. And at the ionosphere level, you would have more frequency and more voltage. And that, which as it turns out, is a more static electricity. That's why as you go in the ionosphere, you can collect static electricity. So this would be the static end. And as you get closer to the Earth, it's where you have a more magnetic energy. All right. So that's moving diagonally this way and this way. So between frequency and voltage, you have a higher frequency and voltage in static electricity, and you have more amplitude and amperage in magnetic electricity. And this graph, this way of looking at this is the reason that anti-gravity works, and so that the center of the graph becomes the center right here. And this would be the ionosphere, and this would be the Earth. And so this is why anti-gravity works, because you are flipping the mirror image of the Earth, and then gravity, which becomes here instead of here, is now pulling in this direction. It's a reversal of the plane. This ties electricity as a whole together for everything from static electricity to magnetic electricity, from the Earth to the ether, and from gravity to anti-gravity. Also, this explains why light acts like a wave and a particle. This whole picture right here is the underlying explanation, and when I get it completely worked out, it will make so much sense, and maybe to some of you it already is starting to click. But I have to get a way to better express the terms in which I'm trying to explain this. But I don't know. I hope someone can like maybe put this, what I'm trying to say, together in a better presentation.